Hey there, Emmanuel here from Tech with Tourists. Welcome back. In this video, I want to go over one of the biggest problems with using AI agents, and that is they make mistakes, and then we have no way of verifying that the solutions that were implemented, whether that is a bug fix, a feature that you're implementing, actually works. So the old way is that the AI writes code, and then the AI claims it works. I'm pretty sure that if you've been using tools like Claude Code or Codex, then you know that this happens all the time. You tell Claude Code, hey, I need you to implement this, I need you to fix this bug, and then it comes back and it says, oh yeah, this is working, you can rest assured, it is now properly working, so the bug is either fixed, the feature was correctly implemented, you can continue working on stuff, and don't worry because I got you, so it is all working. And then you actually try to run things and you see that that's not really true because you decided to either trust the AI, you hope that things would work, or sometimes you might even hop onto the code and manually look at stuff. But the reality is that this approach really doesn't work because we rely on just hoping, again, trusting, and not knowing, not having a concrete way to know that things are rather working. And that is very important for our work since it is important to know that things are working and they are reproducible. So the quote unquote new way, and this is something that I've been doing recently, is that the AI writes code and then the AI needs to prove that it actually works. So stuff like builds running and being able to start a dev server, tests passing, and servers responding accordingly. This means that we are relying on reproducibility and, like this says here, evidence instead of claims. So we don't want to rely on claims for the AI, from the AI agent. We don't even want to rely on our own assessment of things when we hop onto the code and we take a look at things and we try to understand what's happening. Instead, we want to rely on clear outputs, clear evidence, and stuff that is reproducible, and most importantly, even than this, that is automatable. Because by making these things automatable, it means that not only can we go there and run this type of checks, these verifiable outputs, but it also means that the AI agent can do some work, verify its output, see that it either works or it still doesn't work, and then continue doing that same loop until things are working correctly. So here's an example. Just a couple of minutes ago, I was working here on a project and the AI agent found unprotected security functions. I was doing sort of like a security review, and then the AI proposed a change, which is basically to convert a public function into an internal function, internal mutation with convex. So my first thought was, how can we actually verify this? Is there a way for us to verify that after doing this change, this problem doesn't exist anymore? And maybe even being able to verify before the change that the security issue is there, do the changes to the code base, and then verify that the security issue is not there anymore. So what the verification that I arrived at looks like is the following. So first we have the code pattern being correct. So we grab the source and we see that the function that we had there is not there anymore. That is the first step. It is good, reproducible, automatable, so it seems fine. Then we have the API not publicly exposed. So we do that by checking the generated types with convex. We run the convex dev server, we run the command in the terminal, and then it updates the generated types. We then also check the generated types by using something like grep, and we see that it indeed is not there anymore. And finally, we run a runtime check to see that actually it is blocked. So the method here is to spin up the server and try the call. So we can also combine this with something like creating a temporary page where we try to import the previously existing function. We try to run things and we see that it indeed is now working and things are secure. The important thing here is that all of this is automatable and all of this is reproducible. Again, this is the name of the game with AI agents. We cannot trust anymore our own assessment because we do not have anymore the knowledge to know exactly what's happening inside every part of the code base, inside every corner of the code base, inside every line. Previously, yes, we were able to do so. If we were working on a project that we had total control over, we knew exactly what was happening here, what was happening there. We knew that if we changed this line, that would break, and all of those things were great. We were in control of things, but now this is a new way of working, and it means that we need to adapt our methods and our way of doing things. In this case, I think this is a great method, a great way to actually build good features, build good software with AI agents, and still get like the same output, the same outcomes with them by making sure that everything is reproducible and automatable. So the prompt, quote unquote, that changes everything. And this is not only a prompt, this is also like you can include skills here, you can include Claude Code hooks, you can include all of those things that help you automate this stuff. But the idea behind all of this is that instead of just saying, hey, go ahead and fix this bug, we want to say, okay, either use the AI agent to sort of get some ideas for this, or you yourself can sort of take control here and say, okay, this is what we want to reproduce and prove it is true inside the code base before the fix. After the fix, we want to ensure that this is happening. And this means that we ask for evidence, and we get evidence, we get outputs that are actually reproducible. And again, with tools like Claude Code, Open Code, it means that this is even simpler to do. So yeah, this is it. Basically, these kinds of ways of thinking about using AI agents means that we can actually use them for stuff that is important, for work that is important, besides just doing stuff like in the previous videos I talked about personal development tools, personal tools using AI agents. And I think that use case is amazing. It is one of the best ones, but also when I'm working here for stuff that actually means that it's going to be put into production, that people are going to use, I want to make sure that things are actually working correctly. And this is the best way that I found to ensure that the AI agents actually work in a way that helps me know again that things are working. This is the most important thing. You basically want to think in terms of, okay, the changes that are going to be done to the code base, can they actually be proven to fix the thing that we want to fix, and what are those ways? And then just tell the AI agent to verify those things at the end. You can rely on the AI agents like telling the truth, quote unquote, about that. That's usually not a problem anymore with the models. Or you can also rely on your actual tools, in the sense of, like, for example, Claude Code. You can add a temporary hook into the session that you have. Then it means that the AI agent, when it stops, for example, the loop, it goes through the hook, it activates that hook, and then you can have some kind of output there. If it works, then the AI agent can stop the loop. If not, it can continue. This is actually a recent idea that you might have seen around, the Rolf plugin, which I might actually do a video on and get a bit deeper into that topic. But yeah, this is basically like the idea that I wanted to share here, which is very important. Just the automatable nature of like the work that we are doing here with AI agents. And this means that we need to think about our code bases in a different way. It's just that simple. Instead of just relying on the old patterns, the old ways of doing things, we need to be a little bit more creative with how we're doing things, and just try to see how we can still get good software out of these tools. And that's the name of the game right now. So yeah, this is it. I hope you enjoyed this video, and I'll see you on the next one.